Hello students, I am Professor Mandar Dikshit from Electrical Engineering Department. Today we will study the concept of star-delta conversion technique used in DC circuits. We know that by using series or parallel circuit rules, we can reduce or simplify the circuit. But there are some networks in which the resistances are neither in series nor in parallel, and they are connected in star or delta connection. In such situation, it is not possible to simplify the network by series parallel rules. Hence, by converting delta connection into equivalent star connection and vice versa, a network can be simplified and application of series parallel circuit rules is made possible. To understand this, let us draw the star and delta connection. This is my delta connection. Let us number these nodes 1, 2 and 3. The resistor connected between 1 and 2 is R12. Resistor connected between 2 and 3 is R23. And resistor connected between 1 and 3 is R31. Now this is my star connection with terminals 1, 2, 3 and I have a common terminal S. The resistors connected in 1, 2 and 3 branches are R1, R2 and R3. If you observe, the delta connection is a closed loop concept or circuit, and a star connection can be formed whenever the 3 resistors or 3 branches are meeting at a common point. Then we can call it as a star connection. These two connections will be electrically equivalent if the resistance as measured between any pair of terminals is same in both arrangements. Considering the connection diagram of delta connection, the total resistance between terminals 1 and 2 will be given as R12 parallel with R23 plus R31. Now this is the modified diagram of delta connection. Terminal 1 and terminal 2 are taken outside for simplification. Now if you observe the resistance between 1 and 2, R12 is one resistor and second branch is this branch. Hence, this branch becomes a series branch having two resistances R23 and R31, and this series combination is parallel with R12. Hence, we can write down as the resistance between 1 and 2 will be given as R12 parallel with R23 plus R31. Now, by parallel rule, we can write down this as R12 into R23 plus R31 divided by R12 plus R23 plus R31. Now referring to star connection, similar to delta connection, this star connection is modified like this. I have extended terminal 1 and terminal 2 outside for simplification. Now here also resistance between 1 and 2 terminal pair is given as, if you observe the terminal 1 and 2, this will be the resistance between 1 and 2. As R3 is not connected either 1 or either 2 for 2, so resistance between 1 and 2 is given by R1 plus R2. Since the two networks are electrically equivalent, we can write down that the resistance between terminal 1 and 2 for delta and resistance between terminal 1 and 2 for star are equal. R1 plus R2 is equal to R12 into R23 plus R31 divided by R12 plus R23 plus R31. This portion is for star connection and this portion is for delta connection. Similarly, it can be shown for other terminal pairs also, like 2 3 for delta and 2 3 for star, and 3 1 for delta equivalent with 3 1 for star. The equations for other terminal pairs are for 2 3 then for 3 and 1 let us give number to this equation. Equation number 1, equation number 2 and equation number 3. Equation number 1 is for pair 1 2. Equation number 2 is for pair 2 3. And equation number 3 is for pair 3 1 for both connections. Subtracting equation number 2 from equation number 1, we get R1 minus R3 is equal to R12 into R31 minus R23 into R31 divided by R12 plus R23 plus R31. That will be considered as equation number 4. Adding equation number 4 and equation number 3, we get R1 is equal to R12 into R31 divided by R12 plus R23 plus R31. Similarly, we can get equation for R2 as R2 is equal to R23 into R12 divided by R12 plus R23 plus R31, equation number 6, and R3 is equal to R31 into R23 divided by R12 plus R23 plus R31. Let us write down equation number 5 also. Equation number 5, equation number 6 and equation number 7 is the expression which is used to convert a delta connection into equivalent star connection. Thus, a star resistance connected to a terminal is equal to product of the two delta resistances connected to the same terminal divided by sum of all delta resistances. So R1 is the resistance of star connection connected for terminal 1, which is equal to product of two delta resistances connected to same terminal. For terminal 1, R12 and R31 are resistances connected in delta. So product of that two resistances divided by addition of all three resistances in delta. That is R12 plus R23 plus R31. Now from equation number 5, 6 and 7, we will derive expression for conversion of star connection into delta connection. Now multiplying equation number 6 and equation number 7, we will get this equation. R2 into R3 is equal to R23 square into R12 into R31 divided by R12 plus R23 plus R31. We will multiply equation number 5 and 6 and we'll get equation as multiplying equation number 6 and 7, we get equation as R2 into R3 is equal to R23 square into R12 into R31 divided by R12 plus R23 plus R31 sum square. Similarly, we will multiply equation number 5 and 6, which will give you equation as R1 R2 is equal to R12 square R23 into R31 divided by R12 plus R23 plus R31 whole square. And multiply equation number 7 and 5, we will get equation as R3 R1 is equal to R31 square into R12 into R23 divided by R12 plus R23 plus R31 square. Let us give numbers to this equation. Equation number 8, equation number 9 and 10. By adding equation number 8, 9 and 10, we get or just simplify the equation. By adding equation number 8, equation number 9 and equation number 10, we will get this equation and then we will simplify the equation and finally I will get R1 R2 plus R2 R3 plus R3 R1 is equal to R12 into R3. Now R3 will be replaced by this portion as from equation number 7 we get R3 is equal to R31 into R23 divided by R12 plus R23 plus R31. So we will replace this term by R3 and finally I will get the 3 resistor equation as so I get 3 equations of R12, R23 and R31 which are equations of conversion of star connection into delta connection. Hence, a star connected resistance can be converted into delta resistance as delta resistance between any pair is equal to addition of the two resistances of respective terminal in star plus product of that same resistances divided by the third remaining terminal resistance. Thank you for watching this video.